The goal of doing a trig proof is to prove that one side of the equation becomes the other side of the equation. You won't be allowed to work with or manipulate both sides. So what you usually want to do is you usually want to start with the messier side and prove that it simplifies down to the prettier side. So on this identity, on the exploration, what we would do is we would start with the sine of theta over the cosine of theta. And what we would do is we would prove that it becomes the tangent. We're not allowed to manipulate the tangent or rewrite it at all. So we would just use algebraic methods to do that. And we would use other identities to do it as well. So the identities we're actually going to use for this one, and there's more than one way to do almost every proof, but with enough practice you figure out the best way or the simplest way. And so the identities that I'm going to use this time are just your basic SOHCAHTOA identities. Sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse. And so by rewriting it like that, what you've just generated is a fraction that's being divided by another fraction. And so then the next thing that you would do is you would rewrite it as multiplying by the reciprocal. So it's still opposite over hypotenuse, but then it would become multiplication by the hypotenuse over the adjacent side. And the two hypotenuse portions would reduce or cancel out. And what would you be left with but opposite over adjacent, which is, once again, the SOHCAHTOA definition for tangent. And so you've just proven that sine and cosine does in fact create tangent. Now when you start the homework, I'm recommending that you guys only start with the front. And the front isn't proofs, the front is simplifying, because you need practice taking things and simplifying them down to do proofs eventually. So we'll work on the proofs on Monday. They're on the back of the homework and they are messier. So what we're just going to do is practice this. It said that the goal was to try your best to create a single trig function with no fractions left in this. So I'm going to take this trig expression, and one of the, I guess, most consistent methods that you would want to use is using your quotient identities, which means knowing what your trig functions are in terms of sine and cosine. So what that means is, for this problem, this is already cosine. There's nothing that you could do to rewrite it. It's going to stay cosine. But it's being multiplied times cosecant, and cosecant is the reciprocal of sine. So what we could do is rewrite it as 1 over sine. And then those two things would multiply together. And so remember that this is cosine of t over 1. So when the two things multiply, the cosine only multiplies to the numerator. So we have cosine of t on top, and we have sine of t on bottom. Now this isn't a step that we would normally do. I just want to refresh your memory that we, as in the exploration, in fact, we just proved that tangent is sine over cosine. So if tangent is sine divided by cosine, then cosine divided by sine is cotangent of t. And we've met the requirements. What we have generated is a single trig function, cotangent, with no fractions left in the trig expression. Okay, so then I'm going to jump to number 6, because number 6 is a messier problem. And so you've got a variety of options as to how you do this. I'm going to probably do it twice for you guys, do it 2 different ways to show you 2 of the most common ways that we would do this problem. The first way is that we would use our first Pythagorean identity. And remember that the first Pythagorean identity was the identity that said sine squared theta plus cosine squared theta is equal to 1. And so what I would do is I would take this 1 right here and I would replace it with sine squared of t plus cosine squared of t. And then the numerator still had that minus sine squared right there. So I rewrite that part, and it's all over sine squared of t. And so what's going to happen is in the numerator, these two sine squareds are going to add up to 0, and they're going to cancel. And so we will have cosine squared of t left on top and sine squared of t left on bottom. Now, once again, this next step is one that we typically would not require that you show. I normally wouldn't show it, but I do, once again, I want to remind you of something. Cosine squared of t is the same thing as cosine of t, the entire quantity being squared. Make sure that you write it that way, one of these two ways. You can't write it like this, because then it's the angle t being squared, not the cosine value. But what that also means is that this fraction is the same thing as cosine of t over sine of t, quantity squared. And you don't have to show that step. You don't have to write it like that. But the reason that you might is that it might make more sense that cosine over sine, as we just discussed, is the definition of cotangent. And so the fact that that whole fraction is being squared means that what we have is cotangent of t, cotangent squared rather, of t. Now I will tell you that, like I said, this step right here is not one that we typically require that you show. So if you understand that cosine over sine is cotangent, so cosine squared over sine squared is cotangent squared, you can go straight from here to there and be done. And once again, what you've created is a single trig function, cotangent, and it's being squared, and there are no fractions in the trig expression. Okay? Now the last one for now that I'm going to do for you guys is number 8 from that homework as well. This one is a little bit messier. Oh, actually, I'm sorry, I forgot to show you guys a second way to do this problem. It's optional, but it will come in handy later. So I'm just going to erase here and create a little bit of space. It does require that you remember more than one of your Pythagorean identities, though. Okay, so your other option is to split the fraction up. This fraction right here is the same thing as 1 over sine squared of t minus sine squared of t over sine squared of t. Because those two fractions right there that I've just written, they would have been able to subtract because they have a common denominator, and what they would have generated would have been this fraction that we started with. And then the reason that you might want to do that is that 1 minus sine squared is cosecant squared of t, and sine squared over sine squared is 1. Okay, but once again, that requires that you remember your other Pythagorean identities. There are actually 3 of them, and one of them says that cotangent squared of theta plus 1 is equal to cosecant squared of theta. And so that Pythagorean identity tells us that this part right here, cosecant squared minus 1, is the same thing as cotangent squared. But you would only go that route if, number one, you remember that this fraction up here can be split up into 2 separate fractions, and if you also remember all 3 of your Pythagorean identities. So more people will go with the first route to solve that problem. And now the last problem, you have that same option. You could split this fraction up. It's still not really going to make it a pretty process. This is the ugliest problem I'm going to do for you guys right now. And I actually want to show you a method for simplifying fractions, just to make sure that you guys have seen it, either from me or if you have seen it before from a previous teacher. So I'm still going to use my quotient identities. Remember, there are fail-safe. They're our usual route for doing problems. So I'm going to take secant right there, and I'm going to replace it with 1 over cosine. The other cosine in the numerator, there's nothing I can do with it. It was already cosine. And the same thing with the sine of t in the denominator. They were both already in terms of sine and cosine. Now it looks like what I've done is generated this enormous mess, but there's a shortcut for simplifying fractions embedded within fractions. And that shortcut is to take your common denominator and distribute everything through by it. So I only have one fraction in this entire thing, and it's got a denominator of cosine. So I'm going to take my large fraction and multiply through by cosine of t on top and cosine of t on the bottom. And when I take that cosine of t right here and I distribute here, it gets rid of the fraction and just leaves a 1. When I distribute here, it leaves minus cosine squared of t. And when I distribute here, it just leaves sine of t times cosine of t. Okay? Then what I would do is I would use my first Pythagorean identity. 1 minus cosine squared. We've now proven that 1 minus cosine squared is sine squared. We've already simplified that in a previous proof. So I can replace that numerator with sine squared. And what that allows us to do is it allows us to reduce one of these signs with this one down here, which leaves us with a single sine of t in the numerator and just the cosine of t in the denominator, which once again is the quotient identity for tangent of t. And so this messy fraction simplified all the way down to become tangent. And so I want you guys to try, if you have time, just the front of the homework, just the odds. Remember, it's not due till Tuesday. Monday in class, I'll be answering questions on the front and then also helping you guys start and work on the back of the homework. Have a good weekend. See you later.